Welcome to our webinar today. Thank you very much for attending our presentation and live demo. You will receive an overview about our recent developments for automated CAM programming. Spatial and ModuleWorks started a very fruitful partnership, and we will show you in the next half an hour our valuable technologies machine tool builders and CAM vendors can use to develop a cutting-edge solution. Let's see together how we can revolutionize the manufacturing process. Our presenters today are Soroosh Eghbali, Head of CAM Automation of ModuleWorks. My name is Markus Hübner. I am Senior Client Executive at Spatial and I will lead through the presentation today. Soroosh will provide the live demo. Please feel free to enter your questions in the chat window below, and at the end, we are happy to answer your questions. Please, let's have a short look now what kind of information we will provide to you today. First, you will receive a short overview about our companies, our expertise, our missions, and about our partnership. Second, we will let you know what kind of trends and challenges we have identified in manufacturing when we have been talking to our customers and prospects. We will introduce to you the feature-driven self-driving CAM, and Soroosh will provide a very detailed and comprehensive demo. And fourth, at the end, we will discuss the benefits. Spatial and ModuleWorks are leading providers for components in their different industries. Robust 3D modeling is Spatial's DNA. Spatial is one of the first component providers in the modeling technology business and has more than 35 years of experiences. Since 20 years, Spatial is 100% part of Dassault Systems. Spatial has more than 300 customers worldwide in 10 different industries. Industry-proven technology used by millions of users every day and expertise of highly qualified experts with strong industry knowledge has been helping customers with innovation. ModuleWorks is a single-source provider of embeddable toolpath and simulation components for manufacturing. These products have been successfully deployed in digital manufacturing, digital factory, and many other areas and industries. ModuleWorks has 75% market share in CAM, which reflects worldwide market leader position. From 200 employees, 75% are being software developers. This shows a heavy investment in research and development. 500,000 of CAM users have been using software with integrated ModuleWorks components every day. Both companies are leading providers in their markets and industries. Spatial provides robust components to import, handle and modify geometries. ModuleWorks provides the CAM including post-processing and simulation as foundation of the manufacturing technologies. The partnership between both is a perfect complement. The close connection and the intelligent linking of the core competencies enables companies to develop cutting-edge solutions. We both have been talking to our customers and prospects and have been identified the following challenges and trends in the manufacturing industry. There is a demand for production of customized parts, small lot sizes down to lot size 1. At the same time, CAM programming could be complex and time-consuming, even for simple parts. CAM programmers need long training cycles before getting productive. Most of our customers confirm good qualified machine operators are difficult to find. Beside the challenges, we see industry trends to provide automation, digitalization, Internet of Things, and manufacturing as a service. Software becomes an important differentiator for machine builders and tool manufacturers to accelerate process-oriented workflows. We see disruptive technologies like easy-to-use cloud-based applications which provide secure access from anywhere. On the left-hand side, you see the manufacturing workflow we are addressing. You see a classical workflow used in many manufacturing companies the same way. A CAD part is imported in a CAM system or on the machine controller. After the CAM process, the part will be manufactured on the machine. On the right-hand side, you see how we would like to automate this given process and how we understand automatic machining. The part will be imported and the complete CAM process, including simulation and post-processing, will be prepared automatically on a computer or probably on the machine controller itself. And by clicking just a button, the manufacturing process will be started. Manufacturers have a lot of requirements for producing their parts. Beside the quality they require, a straightforward process and an integrated workflow from the import of the part during the whole CAM process. In this workflow, the following influencers are involved: CNC machines and CNC manufacturers, machine builders, CAD software, CAD engineers who develop geometries, CAM software, CAM programmers who generate the code for the manufacturing process, even NC code, which is generated by the post-processor, will influence the process. The added value of our combined technologies help to automate the process and provide a more integrated workflow which maximizes the productivity in limited boundary conditions. We provide together standard and native CAD import, graphical and semantic PMI information, nesting and auto-orientation of the part. Additionally, automatic feature recognition and self-driving CAM are main technologies which are combined to increase the degree of automation dramatically. ModuleWorks and spatial technologies will allow to develop a very efficient automatic CAM process. As the result, the machine operator can perform the CAM process by clicking just one button. These technologies are the foundation of the automatic CAM solution, which I will describe as follows: configurable automatic CAM framework application on the CNC controller or workstation, driven by automatic feature recognition and self-driving CAM for manufacturing prismatic parts for all CAD formats. The heart of the solution is our automatic feature recognition, which recognizes pockets, holes, roundings, chamfers, and more of prismatic parts. The self-driving CAM drives the CAM processes automatically and generates the G-code for the machine as simple as clicking on just one button. Let's have a deeper look into the details now. It's time to get a live overview from Soroosh, the head of CAM automation of ModuleWorks, who will show you the powerful and efficient results.
Thank you, Markus, for the introduction. Alongside with the demo, I would like to invoke a couple of slides to conceptualize our vision about automated CAM programming and also give some insights about the process workflow in feature-driven self-driving CAM. In fact, the idea is that the CAM operator enters the job setup parameters when he has received an order for production, and then clicks just on one button to get the G code for the entire manufacturing process. We can enable this vision by combining spatial feature recognition and ModuleWorks self-driving cam technologies, which both run in the background of this system automatically. We have developed this prototype which should portray these front-end and back-end processes relatively in high level. Now I'm going to launch this prototype to show you the major steps which happen in the front end and back end of this application. The first step is to enter the job setup parameters, and for this purpose we are using ModuleWorks Job Setup app. Here you can choose your target CNC machine from your machine portfolio, and I have chosen this machine with this kinematic as our demonstration machine for today. In the Tool Manager section, you can define your tooling based on different tool types and the corresponding dimensions. As you are parameterizing your tool, the tool preview can be seen here on the right side. As you can see, I have already pre-configured 10 different tools, where the first 4 of them are end mill tools in different diameters and lengths for my roughing and rest machining. And I also have 4 different drills, again in different sizes, for my drilling cycles. I have 1 chamfer tool and 1 ball mill to finish corners and fillets. Here we can define tool arbors and tool holders, basically in different methods. One is to load an IGS contour and then the application will revolve it, or we could also load the 3D CAD model of these components. For the tool holders, I have already loaded the holder mesh, and you can see all my holders here in this list. Now, using all these components which we have defined in the tool manager, we can assemble our tools by choosing these components which they appear in this list and stacking them together. We can define the tool ID and tool name here, which I have done already before. What you see here is basically the digital version of what we have in the tool magazine of the machine. Now we are done with the tool manager section, and we go to the setup section. Here in the setup section, we can load the target part geometry and the stock model from your directory. Let me change the color of the nested part in the stock such that you can see it better. Finally, in the fixture section, you can load your fixture again in the same way. And if we go to this section, you can see all the setup parameters together, which means your machine, including the digital tool magazine, and then the fixture stock, which is ready for machining. Now we can save this and go to the next step. Now the only thing our cam operator needs to do as an end user is to click just on this self-driving cam button. As you're seeing on the screen, this triggers all the necessary cam preparation and toolpath calculation for different cycles like roughing, finishing planar faces, pocket machining, drilling, and so on. For our job, the entire process will take about 2 minutes, so I let this running here, and in the meantime try to give you some insights about what is happening in the background of this system automatically. As mentioned earlier, self-driving cam is driven by feature recognition technology, which is running in the background of this system. Just to give you some insight about this, I'm opening the feature recognition simulator tool from Spatial and let the simulation running to see how feature recognition is applied on this. What we have here is the prismatic part that we have input in the job setup step. This has different CAD features on all its sides. In the first step, the yellow face is recognized as the support face which holds the part in the fixture. Here you see the hole detection for all types of holes, basically the blind spot drills on the sides, as well as the through holes and the countersunk and counterbore holes. Likewise, the closed and open pockets are detected too. This one is the detection of the cylindrical boss with the step. And finally, we have the fillets at the edges and inside the pockets detected. Actually, what you are seeing here is breaking down the part to its individual CAD features. And in fact, this is the enabler for our CAM automation. Let's go back to our slide to elaborate on this a bit. Let's have a short recap. The CAM operator entered these job setup parameters: the target CNC machine, the tools, the tool assemblies, the part, the stock, and the fixture. This internally created a job setup file which includes the CAD file for the prismatic part. Feature recognition technology detected the CAD features automatically in the background and measured each individual feature. This information was passed to self-driving CAM, which includes process logics for automatic CAM preparation. Accordingly, each CAD feature, like the hole or pocket, is binded with a matching tool from the given tool magazine, as well as a correct machining direction. This information is enough to put an appropriate machining sequence from roughing, drilling, and pocket machining together and calculate the corresponding toolpath. Lastly, the toolpath is post-processed internally for the target CNC machine, and the software outputs the NC file for the CAM operator. Having everything said, now let's go back to check the status of the self-driving CAM job which we had triggered earlier. As you can see, different CAM operations have been created and calculated automatically. For our sample job, we got 46 CAM operations which we will simulate shortly. Also, these toolpaths have been post-processed for the target CNC machine, and we got this NC file as the output. So now, in fact, everything is ready for the CAM operator to start the machining. Though to visualize the calculated CAM operations, we want to simulate the output from self-driving CAM first. As far as simulation is concerned, ModuleWorks offers different types of simulation tools based on different technologies. For instance, toolpath simulations based on cutter location data, or G-code simulation, or CNC simulation, which is the visual twin of what is happening on the target CNC machine. Self-driving CAM output is compatible with all these products, though in this simulation, I'm deploying G-code simulation, which is powered by our NC editor product. To keep the demonstration short but still simulate the operations properly, I've prepared this video which should highlight the major steps of the machining. Let's watch it together. As you can see on the screen, the first few operations are roughing and planar face finishing with our large end mill tool. Now we got pocket machining and boring, which take place with the smaller end mill tools. Here we have the drilling operations for the countersunk, counterbores and the spot drills. And finally the fillet finishing operation. You can see that our sample part with these prismatic features can be machined perfectly without conducting the classical CAM programming, rather by the automatic CAM preparation method. Now to conclude the demonstration, I would like to highlight the resources and effort required for human-driven CAM programming and compare that with machine-driven method. In human-driven CAM programming, CAM engineers need to manually analyze the part and design an efficient machining process, then assign correct tool and machining direction to each CAD feature, and configure the necessary CAM parameters for each operation, which could be sometimes challenging. Lastly, go to the simulation step to correct the entries and incrementally validate the manufacturing program. All these manual steps take time and require skilled CAM engineers. Also, when topology of the target parts become more complex, the corresponding costs and risk of human failure increase too. But in case of self-driving CAM approach, as you saw in the demo, the preparation for CAM is very easy and can be done even by inexperienced operators independent of the part complexity. Usually it takes just a couple of minutes to load the job setup parameters and then basically you're ready to go, as all the necessary decision making for CAM programming processes will be taken care by the system automatically. So here is a summary. Self-driving CAM concept enables efficient manufacturing for customized parts, which can propose significant value and opportunities for job shops and machine tool builders. Markus, I'm finished with the demonstration section. You can now take the lead and go through the conclusion section. Thank you.
Okay, Soroosh. Thank you very much. This was a great overview. It was a great presentation. Very detailed, very impressive. I'd like to describe shortly how our partners can realize a development project based on this solution. Let's start at the bottom of the slide. We, Spatial and ModuleWorks, will provide our best-in-class development components. Additionally, we provide a lot of added value for automation with our connected and combined technologies for automated CAM. We also will provide our expertise and our knowledge to help to develop a customized, tailored solution which is based on your and your customer's demand. You have to define your requirements and we will help you to realize your customized solution. We will be your partner to help you to focus on your customers. As a CAM vendor or CNC machine builder, the solution will be your own software, not a generic CAM product from the market. You own it, you support it, you can develop it by your own and you can enhance the software for your customers' requirements. You will implement your expertise for your customers and optimize the software for your workflows or for specific machines. CAD on port for all native and standard formats will be provided and make your software independent from any CAD software. This will help you to enter the current CAD ecosystems of different industries. Together with CAD feature recognition and self-driving CAM, an automatic CAM process will become reality for prismatic parts. This solution will grow in the future as you can add further components of Spatial and ModuleWorks. I hope you found this automatic feature-driven self-driving CAM webinar was interesting and useful. Our objective was to give a quick overview of how we address this challenge in the manufacturing industry and what kind of value we can deliver for CAM software developers and manufacturing companies. Before we finish, I'd like to give you a short overview about the benefits. We provide technology to develop a competitive edge solution which will help our customers to differentiate in the market and tailor their software based on their expertise and their customer requirements. Increasing productivity in the manufacturing process with automation is the key and will reduce costs, skipping the time-consuming CAM programming for prismatic parts. Simple parts could be used to have less downtime of the machines because programming time and setup time will be much more efficient through automation. Thanks again to have the chance to show our latest news about feature-driven self-driving CAM. We are coming to an end now and I see there were already some questions. You still have the chance to enter more in the chat window below. We are answering all of your questions later in an email because we are running out of time now. If you would like to discuss a future project, please feel free to come back to us anytime. Thank you, goodbye, and have a good day.